Okay, Assalamu alaikum warahmatullah. This is a revision about the EOT about the chemistry grade 10 advanced. Okay, so let's check the first question. The first question says which figures illustrates evidence of chemical reaction. Okay, so we have some indicators or evidences that we have a chemical reaction. So one of them is about the change in color. And the second one is about the production of heat and light, or let's say the change in temperature. Third one is about bubbles and gases. Okay, the fourth one is about formation of precipitate, which means formation of solid. And by the way, we have physical changes also. The physical changes include the boiling, melting, evaporation, freezing, because here we have a change in state, okay, in physical state. So we have solid, it converts into solid, it converts to liquid or gas or so on. Okay, so the first one here, which figures illustrates the evidence of a chemical reaction. So as we see here, we have a change in color. So this is the first one. Here we have light and heat. We have change in temperature. So this is the second one. Here we have boiling. We have melting. Both of them are not chemical changes. They are physical changes. Okay. So as you see here, we have 1 and 2. So we choose 1 and 2 only. Next question. In the figure below, what is the evidence that indicates that a chemical reaction has occurred? So as we see here, we have a change in color because we have transparent liquid and transparent liquid. So there is a change in color. Here in this question, look at the pictures here. They are looking for the correct. Okay. So as you see here, we have here bubbles, fizzy tablets. Okay. And here we have a change in color, as you see. So in 1 and 2, apple what? There's a color change, okay? And there's a gas bubbles, and they are considered as what? As evidences of what? Of a chemical reaction. So this is the correct answer. Okay, next question. What is the purpose of using the symbol plus, okay, in the chemical equation? So we have a table in the book, and this table included, the symbols that are used when representing the chemical equation. Okay, so this symbol is used to what? To separate two or more reactants or products. So this is the correct answer. Next question, we have this symbol, which indicates to what? To a reversible reaction. Okay, so this is the correct answer. Next one, here, what's the correct balanced skeleton equation that represents a chemical reaction below? So here we have hydrochloric acid. So this is a hydrochloric acid. So this is AQ. Reacts with solid aluminum. So aluminum is solid to produce what? AlCl3, which is aqueous. So that means this is AQ. And this one is gas. So this is gas. So as you see here, we have these are reactants. Okay. And these are the products. Okay. And this is the arrow which separates between the reactants and products. So let's check. The first one, Al solid. Okay. Al solid, that's correct. HCl gas. Is it gas? No, this is aqueous. So this is not correct. And you can check here, as you see here, AlCl3 is liquid here, but here it's aqueous. So this is not correct. So, and H2 is aqueous, but H2 here is gas, as you see. So this is not correct. Let's move to the next option. Okay, Al solid, yeah. HCl aqueous, yeah. Produces AlCl3 aqueous, yeah. And gas, this correct gas, yeah. Maybe this is correct. So let's check the the other options. Okay, so AlAQ, no, Al is not AQ. Al is solid, so this is not correct. So we can cancel it. And as you see here, AlCl3 is aqueous. Yeah, that's correct. But HCl is what? Is aqueous. So this is correct. So because of this, this is not a correct answer. AlCl3 aqueous. Okay, and H2 is gas. Yeah, but they are what? As you see here, they are the products. They are the reactants here. Okay, but in the equation, look, AlCl3 and HCl are what? are the products because they are after the arrow, okay, on the right side of the equation. So they should not be on the left side of the equation. So this is not the correct option. So as you see here, this is the correct option. And but by the way, let's check the balancing. Okay, so is it a balanced equation or no? So as you see here, we have 2al, we have here 2al, we have 6h, we have 3 times 2, so we have 6h. We have 6cl, we have 6cl. Okay. So what about this? They said solid sodium reacts vigorously with water, which is liquid, yields gaseous what hydrogen. So this is gas, and sodium and solution. So aqueous solution, which means AQ. So as you see, we have Na, which is solid, water, which is liquid, to produce or yield the gases hydrogen, H2 gas, and NaOH, which is AQ. So let's check. Here they said Na, which is solid, but they said here water is what? H2O, water is H what? Is aqueous. So this is not correct. Okay. So we can cancel this option. Okay. And here look at the hydrogen. Hydrogen is gas. Okay, gas, but here is aqueous, so this is not correct. Here they said NaOH plus H2O, but the reaction is not between NaOH and H2O. The reaction is between Na and H2O, so this is not a correct reaction or equation. Na and H2O, okay, but Na is what? Is aqueous, but here is what? Is solid, so this is not correct. And by the way, look at water, aqueous is not correct because this is what? This is liquid. Here we have NaOH, which is solid, but NaOH is what? Is AQ, and also not correct. Let's check the last one, okay? Na solid, yeah. H2O liquid, yeah. NaOH, AQ, yeah. This one is gas, yeah. So let's check. 2Na, 2Na. 2 times 2, 4H. 2H and 2H, so we have 4H. 2O, we have 2O, so this is the correct option. Okay, so let's move here. Solution of iron chloride reacts with the solution of sodium hydroxide to produce solid iron 3 hydroxide and sodium chloride solution. What is the balanced equation that expresses what? This equation. So let's check. All of the equations are the same, as you see. AQ, 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 AQ. Solid, solid. Okay, here we have what? We have AQ. Okay, so let's check first. Okay. By the way, they said here we have solid iron hydroxide. Okay, iron hydroxide, which is FeOH by 3. So this should be what? Should be solid. So this is not correct, as you see. Not correct. And this one is not correct also. So we'll check here and here. Okay. So let's check first. Here we have FeCl3. Okay. So we have Fe and Fe, 1 and 1. Cl3 and Cl here is 1. So this one is not correct. Yeah, this one is not correct. Let's check here. Fe1, Fe1, Cl3, 3Cl, 3Na, we have 3Na, 3O and 3H, 3O and 3H. So this is the correct answer. Here, what is the correct coefficient must put in the blank in order the following chemical reaction to be balanced. Okay, so here we have 2s, here we have 1s, so multiply by 2. Okay, and look, let's check. 3 times 2 we have 6O, and 2 times 3 we have 6O, so the answer is 2. Here, which of the following is not an evidence of that a chemical reaction occurs? Temperature change is an evidence. Gas bubbles is an evidence. Color change is an evidence. Decrease in mass, this is not an evidence. Okay. So here they say a piece of zinc, which is solid, zinc, this is zinc, which is solid, is added to a solution of what? Dihydrogen sulfate, or which is called sulfuric acid, which is H2SO4. Okay, AQ. It's a solution. This reaction produces a gas and a solution of what? Of zinc sulfate, which is ZnSO4. Okay, solution. So let's check. So they said here the Zn plus H2SO4, and Zn is solid, H2SO4 is what? Is AQ. Okay, and here this produces what? ZnSO4 plus gas. Okay, so let's check. Here we have Zn. Do you have Pb? No, we don't have lead. Do you have Pb? No, we don't have lead. Okay. Do we have HCl? No, we don't have HCl. So they are not correct. Okay. So this is the correct answer, by the way. So let's check Zn, H2, SO4, SO4. So this is the correct answer. Next question. What are the reactants and products? Reactants before the arrow, or on the left side of the chemical equation. Products are on the right side of the reaction or the equation. Okay, so they are the reactants, they are the products. So as you see here, they are the reactants and this is the product. Okay, so this is the correct answer. Okay, so here what's the evidence of chemical reaction for the following? As you see, we have a color change. So this is a color change. Here, which of the following past chemical equations, okay, represent the following chemical reaction? So there's a solid aluminum, okay, so there's aluminum which is solid with bromine which is gas, to produce aluminum chloride, AlBr3, which is solid. So this is solid. Okay, and by the way, how do we know that this is AlBl3? Because from the trimester 1, okay, we can as you know that Al has a charge of Al plus 3, which is in group 13 in the periodic table. This is from term 1, by the way, huh? And Br is from group 17, so Br is -1. So when you swap between them, you get Al1 and Br3. So we cancel that one, so we have AlBr3. Okay, so let's check. They say here we have Al solid and Br2 gas. That's right. So let's check. Al solid, Br2 gas. Okay, gas. No, this is not correct. And by the way, let's move to the next one. They said Al solid and Br2, sorry, Br2, which is gas, and here we have AlBr3, which is solid. So this is maybe correct. AlBr3 produces, no, they are what? This is what? This is their products, not the reactant. So this one is not correct. This one is not correct. So this is the correct answer. Let's check. 2Al, 2Al. 3 times 2, we have 6Br. 2 times 3, we have 6Br. So this is the correct answer. Next question. Which of the following reactions on the table present a single replacement? Single replacement. So as you see here, we have evidence. We have some, we have 4 main types of chemical reactions in our curriculum. The first one is about the synthesis reaction, which means there's a combination between 2 or more materials or substances or chemicals to produce only one. The second one is decomposition, which is the opposite of synthesis. So there's a one material which breaks down into 2 or more. What about the third one? The third one is the combustion. We have before the R we have oxygen. And it produces light and heat. The fourth one is replacement. We have 2 types of replacements. We have replacement reaction. We have single replacement and double replacement. In single replacement, we have element and compound, which produces element and compound. But in the double replacement, we have compound, and compound, produces compound and compound. Okay, so let's check. They said here single replacement. So single replacement, this is what? This is combination. So this is synthetic. Synthesis reaction. Okay, combination. This breaks down this AB into A and B. So this is actually composition. Here we have single replacement because A replaces B. Okay, so as you see here, we have AX and B. Here we have compound. So this is double replacement. So this is the single replacement reaction. Okay, which of the following is the synthesis reaction? Synthesis reaction, this, because we have combination between A and B to produce AB. Okay. Third, next question, what is the reaction substance? What is a reaction of a substance with oxygen? So there is a reaction with oxygen. The reaction with oxygen is what? Is combustion, which means burning. Okay. So, and it forms heat and light. Next question, which of the following is single replacement or displacement? Sometimes we say replacement or displacement. They have the same meaning. Okay. So single replacement, we have here element and compound. Here we have element and compound. And as you see, Cu kicked out what? The silver, Ag. Okay. So Ag is outside, okay, out of the compound. Okay. And here we have CuNO3. So this is the single replacement. By the way, here this is what this is a combustion reaction because we have oxygen before the arrow. This is a synthesis reaction and a combustion because we have two chemicals, they combine together to form only one, and we have oxygen before the arrow. So we can say that this is a synthesis reaction and combustion reaction. What about this? We have compound, 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 compound. So as you see, this is what the replacement reaction. So this is the correct answer. Which of the following is the synthesis? So as you see, this is the equation, okay? Because we have two chemicals, they combine together to form only one. And you can check the rest of the equations, okay? So this is combustion, this one double replacement because we have compound, 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 compound. This is a decomposition because we have a chemical or one substance which breaks down into, look, 1, 2, 3 chemicals, okay? Here, what's the type of the chemical reaction represented by the reaction below, equation below? This is what? This is the decomposition reaction, okay, which breaks down, okay. So here, let's move to the next question, okay. Using the reactivity series of the metals, what would yield the single replacement reaction of calcium and zinc nitrate? So this is, you have to use this, okay, this reactivity series. So we have calcium here. Where's calcium? This is calcium. Okay. We have here Zn. Ca will try to kick out what? Zn. Okay. Where is Zn? This is Zn. Okay. So can calcium kick out? Okay, the zinc, yeah, because this one is more reactive than Zn. So this reaction will take place and Ca will kick out what? Zn. So we'll get Ca with what? With NO3 and Zn is out. Okay. So which one? We have Zn out and CaNO3 by 2. Okay. No reaction on it, correct? And this one, by the way, is not correct totally because we are in the equation, in the reaction, we don't have chlorine, as you see. But here they added what? Chlorine. So this is not correct. Just, there is a kind of solving the questions by using the elimination, okay? So you can cancel out the incorrect options. So that's better, before when you try to find maybe a mistake in the option, this will reduce the number of the options that you have to search, okay, or look, or try to find the correct answer, okay, deeply. So, why do automobile safety airbag inflate rapidly as sodium azide pellets what decomposes? Okay, decompose. So there's a reaction. The reaction between what? Sorry, there is a reaction. So the sodium azide will decompose, okay, to form a gas, okay. So there is a gas, as you see, airbag. So this is what? Nitrogen gas, not solid, not vapor, not liquid, just a gas. Look, there's a gas inside it. Next question. Using the activity series of metals, which of the following reaction doesn't occur? Look. Pb and Ag. Pb is lead. Where is lead? Lead. This is lead. Okay. And Ag. Where is Ag? There is Ag. So Pb can kick out what? Ag because it's more reactive than Ag. Ni. Can Ni kick out Ag? Let's check Ni. Ni. Where is Ni nickel? And this is Ni. it can kick out what? The AG. So this can take place, okay? AU and AG. AU is below AG, so it cannot, it's not able to kick out what? The silver. So this is the correct one. What about CU and AG? Yeah, CU can kick out what? The AG, because it has higher reactivity than AG. Okay, so this is the correct answer. Next question. What happens when an aqueous solid sodium hydroxide solution is mixed with solution of what? Of copper 2 chloride. Copper 2 chloride. Okay, so there's a reaction between them. So look, what's this? This is precipitate. Look, is what? Precipitate. So there's what? There's a reaction. So as you see, we have sodium hydroxide. So we have sodium hydroxide. Okay. And copper 2 chloride. Okay. And by the way, both of them are what? Are aqueous. Okay. And this is a double replacement reaction. So we will swap this. Okay. Hydroxide and chloride. So we'll get sodium chloride and copper hydroxide. Just swap them. Okay. So we'll get here sodium chloride and copper 2 hydroxide. Okay. So let's check. No visible reaction occurs. No, there's a chemical reaction occurs, because here we have, as you see, we have here a solid. Okay, precipitate. So this is not correct. Solid copper metal is produced. Do you have solid copper? No, because copper is not, separated. Copper is part of the compound. So this is not correct, because we don't have copper. And here, chlorine gas. Do you have a chlorine gas released? Look, do you have chlorine gas? No chlorine gas released. So this is not correct. Let's check this. Solid hydroxide. Okay, sodium precipitates. Okay, out of the solution. Look at the precipitation here. So this is an indicator of the precipitate. Okay. Next question. Using the halogen activity series, what would yield the reaction of the chlorine Cl2 with aqueous fluorine HF? Okay, so Cl will try to kick out what? The fluorine. Now, why not hydrogen? Because hydrogen is not mentioned here in this series. Okay, this is halogen and this is halogen. Okay, so Cl. Where's Cl? This is Cl. Can Cl kick out the fluorine? No, because it's less reactive than fluorine. So there is no reaction here. Okay. Next question. Using the chemical activity series in the figure below, which of these chemical reactions does not occur? Does not occur. Let's check. Cu and Ni. This is Cu, which is copper, and Ni. This is Ni, nickel. Can Cu kick out Ni? No. So this is the correct reaction, because they say here doesn't occur. Okay, because Cu cannot kick out what? Cannot replace the Ni. Okay. So this is the correct answer here. Which of the following solutions is an ionic compound? Ionic compound. So sucralose is not, because this is a covalent compound, so this is not correct. Okay. They said here hydrogen chloride, not correct. Ethanol, not correct. How do you know? By the way, ionic compound is made up of what? Of metal and non-metal. Okay, non-metal. So here, sodium is metal and the chloride is non-metal. So this is what? This is the ionic compound. Okay. Next question. What is the complete ionic equation? What is the complete ionic equation? To get the complete ionic equation, just break down all the aqueous solutions, okay, and keep the solid, liquid, and gas in the same formula. Okay, don't break them down. Okay, so look here. What do we have here? We have AQ. Okay, so if we break it down, we have 2Li and SO4. Why not 4SO? Because 4 has what? Has the 4. Okay, so 4 belongs to what? To oxygen, not S. So if we wrote, for example, 4SO, so that means this 4 is multiplied by 4 by S and O. Okay, but here SO4, so 4 belongs to what? To O, not S. Okay, but here look, Li, we have 2 Li. Okay, and here let's break it down. So we have Ca, and how many NO3? We have 2. So we say plus 2 NO3. Here let's break it down. What do we have here? We have 2 Li and 2 NO3. 2 Li and 2 NO3. What about this? No, keep it the same. Why? Because we don't break down the solid, liquid, and gas. Just break down what? The aqueous. So as you see, which one may be similar to this? Okay, let's check here. No, that's the same. It's not correct. And here, what do we have? We have 2Li and SO4. Okay, 2Li and SO4, Ca and 2NO3. Yeah, here. What's the mistake here? They didn't break down what? This. And look, if you can see here, this is what? This aqueous. Okay, what did they write here? They said solid. Okay, same material. Look here, aqueous. Here what? Here solid. So this is not correct at all. Okay, here, what do we have here? We have solid. Look, they break down what? They break down the solid. Okay, so this is not correct. Here, let's check this one. 2Li, yeah, 2Li, SO4, SO4, Ca, Ca, 2NO3, 2NO3. This one is broken down. Okay, is broken into what? Into 2Li and 2NO3, 2Li, 2NO3, and CaSO4. They keep it the same, so this is the correct answer. Okay, let's move. What is the complete an equation of their further reaction? Same, okay, same as the previous question. So here, this is not correct because that doesn't include the all the ions. Okay, so this is not correct, and this one is not correct, by the way. Here, let's check here. Look here. What do we have here? We have solid. Okay. What do we have here? We have aqueous. What did they write here? Solid. Look, the same substance, but there's a mistake. So this is not correct. Here, 2Li, 2Li. So we have 2Al plus 2 times 3. We have 6Cl. Okay. What do we have here? 6Na and 6OH. Okay. What do we have here? 6Na and 6Na. Sorry, 6Cl. This is solid. We don't break it down. Okay, so ALOH by 3. Okay, so this is the correct answer. You can double check here. 2, 6, 6, 6, 6, 6, and this is not broken down. Okay, so let's move. Why is the reaction that forms water? No evidence. Water, no evidence? Yeah. Why? Because we cannot see the water. Okay. Water is colorless, odorless, and already makes up what? Most of the solutions. So this is the correct answer. Next question. Which of the following reactions in aqueous solutions below produces gas? Produces gas? Yeah. Gas means that we should have G in the products. Where? This is the gas. Where? After the arrow, as you see. Here we have water, okay? And here we have water, and here we have the precipitate, which is solid. So we have G, gas. We have S for solid, or we say precipitate. Okay, and we have L, which is H2O, by the way. H2O, which is liquid. Sorry, liquid. Okay, which is water. Okay, so this is the class. Here, which of the following produces precipitate? Precipitate. So we said here the precipitate is what? Is the solid. So where is the solid? Where is the solid? No solid here. We are looking up. We have to look for the solid in the products, not in the reactant, by the way. This is for to produce water, this is to produce gas, this is the solid. So this is the correct answer. Okay, so what is the net ion equation? To find the net ion equation quickly, okay, just go to the products and break down the the substance which is not aqueous. Okay, so to find the net ion equation quickly, okay, just go to the products, okay, and look for the substance which is not AQ. Okay, so this is not AQ, this is solid. Break it down. What do we have? We have Ca plus 2H. So this is the equation. This is the equation. Ca plus 2H produces what? COH by 2. This is the correct answer. Okay, here an ionic equation that shows all the particles. Okay, all the particles. This is what complete an equation. Okay, what's the meaning of the spectator ions? Spectator ions, as you know, that the spectator ions that ions don't participate in the reaction. So there is no rule. Let's say there is a rule book, okay, but we say that they don't ions don't participate in the reaction. Okay. Here, net ion equation for the reaction. As we said, the net ion equation we have to go to the products and look for the substance which is not an aqueous. Okay. So this is not aqueous. So in this aqueous, you cannot use it. Okay. So break it down. What do we have? We have 2H plus 2Cn. Okay. To produce what? To produce this substance. Where is it? This is the reaction. 2H plus 2Cn produces 2HCn. Okay. What is the solvent and aqueous solution? They said solvent. Okay. Solvent and aqueous. So this is what? This is the water. Because the solvent and aqueous solution is what is always is water. Okay. Next question. Study the following figure. How the solubility of saccharose, table sugar, C12H12O 12 or 11, sorry, differs than sodium chloride. So this is what? This is a compound, okay, which has covalent bond. Okay. Here the sodium chloride is an ionic compound. Okay. So as you see here, this is what sodium chloride. Look at the sodium chloride. It breaks down into Cl and Na. Cl and Na. Here, look at the saccharose. Look, same. The molecule. Okay, the molecule itself doesn't break down. Okay, so sodium chloride will dissolve in water and form ions, while saccharose will exist as molecules. Yeah, that's right. Look, because sodium chloride breaks down into what? Into ions, as you see. This is the ion, this is the ion, this is the ion. Okay. Which one of the following reactions an aqueous solution produces gas? Gas, this is the gas in the product, and the product. What's the type of the chemical reaction? Showing below. So we have compound. So this is double replacement reaction. But you see here, we have, what do we have here? We have solid. Solid means precipitate. So forms what? Precipitate, because we have solid. So this, for this, we have to find H2O, which is liquid in the products. This, we should have what? G in the product. Okay. Which, when chemical reaction takes place between Na2S and MgNO3, okay, a precipitate of MgS is formed. What is the net ion equation? Okay, so this and this will react to produce what? MgS. So MgS, which is what? Precipitate. Precipitate means solid. Okay, so how to get the, and there's, there's NaNO3 here in the products, but here they said what is the net ion equation. So take this and break it down. Break it down into what? Mg plus S to produce what? To produce this, which is MgS. So this is the correct answer. Mg and S to produce MgS. Okay. And here, the addition of hydrochloric acid and two test tubes containing solutions, either sodium chloride and AgNO3 causes a white precipitate. Okay, which of the following statements is correct? Okay, so here what do we have here? We have HCl and AgNO3. HCl and AgNO3. What do we have here? We have HCl and NaCl. Okay, so let's check here. We have here HCl and AgNO3. Okay, so double replacement. So you will swap between H and Ag or Cl and NO3. Okay, it's up to you. So we have AgCl and HNO3. Okay, what about this? We have HCl and NaCl. Okay, can we replace Cl with Cl? Yeah, so there is no reaction here. So sorry, no, so there is no chemical reaction here. So there's a chemical reaction only in one. Okay, so precipitate forms in test tubes of 1 and 2, not correct. Will not form in both of them. No, it forms in the first one. Oh, sorry. This is the first one. This is the second one, by the way. Just be careful. Look, we have here 1 and 2. So 2 is correct. 1 is not, will not produce a chemical reaction. So they said here, precipitate forms in both test tubes, 1 and 2. In 1, no, there is no chemical reaction. Will not form in both of them. No, it will form. No, it will form in what? In the second one. So this is not correct. We are looking for the correct answer. In test tube 2, yeah, it precipitate, yeah, will form in the test tube 2, and no precipitate in the test tube 1. Yeah, this is the correct answer. Because in 1 we have a reaction. Okay, and by the way, this is the solid and this is the aqueous. So this is the precipitate. Here, here this is the second chapter, which is about the mole. The mole. Okay, so let's remember together. Okay, how to convert from mole. Okay, we have mass, we have mole, we have particles. Okay, we have 4 types of particles here. We have formula unit. We have ions. We have molecules. And we have atoms. Okay, atoms. How to convert from mole to particle? By multiplying by what? By 6.02 times 10 to the power 23, which is the Avogadro number, over what? Over 1 mole. Okay. In the opposite side, we have to convert. If we need to convert from particle to mole, we multiply by 1 mole over 6.02 times 10 to the power 23 particles. Now, from mole to mass in grams, by the way. So sometimes they don't say find the mass, they say how many grams. So this is the same. Okay. So from mass to mole, we have to multiply by what? By 1 mole over the number of grams. Okay, how to get this? This is equal to the molar mass. Okay, which we can find it in where we can find it in the periodic table. Okay, so molar mass, 1 mole over the value of the molar mass. Okay, in grams here. Okay, and in the opposite we have to swap. Okay, so to flip it. So we have here 1 mole in the denominator, and we have here in the meter we have the gram. Okay, so let's move and check what is the correct ascending order. The correct ascending order. Ascending order means from the smallest to the largest. Okay, about what? The number of moles. Okay, so what do we have here? We have here 3.75 times 10 to the power 25 atoms of Zn. Okay, and this is the first one. The second one is 3.65 times 10 to the power 24 molecules of C6H12O6, and the third one is 18.8 moles of what? Of Fe. So look here they want me to find it in what? In moles. Okay, so we have here atoms, we have here molecules, we have here moles. So this one doesn't need to convert. Okay, but this one we have to convert it. How to convert from molecule to mole? Molecule, which is particle. Okay, 2 mole, you have to multiply this by 1 mole over 6.02 times 10 to the power 23. Okay, I will try to find the answer. Okay, so what do we have on the calculator? We have 3.65 times fraction 1 over 6.02 times 10 to the power 23. Okay, so the answer, just a moment, here times 10 to the power 24. So the answer is 6.06. Okay, so equals 6.06 mole. So by the way, how to find it? Using the calculator. This is the calculator. Okay, and here, let's check. So as you see here, we have 3.65 times 10 to the power 24. Then we multiply it by the fraction here. We have 1 here, and down we have 6.02 times 10 to the power 23. Okay, equals, this is the answer, 6.06. Okay, moles. What about the second one? Here we have 3.75 times 10 to the power 25 atoms. So multiplied by 1 mole over 6.02 times 10 to the power 23. I will try to find it on the period my calculator. So here we have 25, and here we have 7. So the answer is 62.3. Okay, 29. So let's say round it up. So mole. Okay, so here we have 18.8 mole. Here we have 6.606 mole. Here we have 62.3 mole. Okay. So which one is the smallest? This one is the smallest. Then this is the first one. This is the second, and this is the third. Where is it? This is the answer. 18 mole, and this is the molecules of 6,6H12O6. And here, what do we have? Here we have Zn. Okay, so this is the correct answer. Okay. Which of the following is not does not describe the mole? Okay, the mole. So the mole. They said here Avogadro number of molecules of a compound. Okay, so this is the definition of the mole, but we are looking for the incorrect. Okay, a unit used to count particles directly. No, not directly. This is not correct. The SI base unit used to measure the amount of substance. Yeah, SI base unit. Number of atoms exactly in 12 grams of pure carbon 12. Yeah, this is correct. So this is the answer. Okay. Here, what do we have? We have what's the number of atoms in 0.645 moles of argon. Okay. And by the way, this is the Avogadro number. So how to convert from mole to particles, because they ask me to find the number of what? Of atoms. Okay. So I have to convert from mole to what? To atoms. So 0.645 mole. Okay. Times 6.02 times 10 to the power 23 over 1 mole. Okay, so we can cancel mole with mole. So the answer 0.645 times fraction. We have 6.02 times 10 to the power 23, and down we have 1. Okay, so the answer is 3.88 times 10 to the power 23. Okay, so as you see, just simple conversion between from mole to particles. Okay, for the next questions, I will write the formula, then you will try to find it by yourself. Okay, and then you can check the answer. Choose the answer, the correct answer. So how many moles? What do you have here? We have molecules. Okay, so what do you have? We have molecules. How to convert from molecules to mole? So 2.50 times 10 to power 24 times the number of particles, sorry, the 1 mole over 6.02 times 10 to power 23. Okay. So you can, use the the calculator and find the answer. Then you can choose it here. Okay. From here. So how does the chemist count the number of particles in each number of moles of particles? Okay. So they said here how to find the number of particles in what? In 1 mole. Okay. So they said here using dozen count what? 12. No, not 12. 6.02 times 10 to the power 23. So using Avogadro number, which is 6.02 times 10 to the power 23 representative particles, this is the correct answer. Okay. Using molar mass, no, not gonna using the molar mass and mole ratio. Using the number of carbon and isotopes, no, because this is the definition, by the way. Okay, one of the definitions of the mole. Here, uh, here, how many formula units? Formula units means particles. So what do we have here? We have 0.75, 0.75 mole. Okay, multiplied by what? By 6.02 times 10 to the power 23 over 1 mole. So you can use the periodic table to find the answer, then you can choose the correct answer. Here, what is the correct ascending order? Okay, this is similar to the previous one, to that question. This question similar to this one. Okay, this one. So you can solve it by yourself by just following the same steps of this question. Okay. Here let's move to this one. How many atoms? We have 2.50 moles. Okay, we have 2.50 moles. We have 2.50 moles, and we have to find what? The number of atoms. What do you have to do? 2.50 mole times 6.02 times 10 to the power 23 over 1 mole. Cancel mole and mole. Okay, so you can find the answer. Okay, which is this one. So here, same 1.22. So 1.22 mole times Avogadro number 6.02 times 10 to the power 23 over 1 mole, and you can find the answer. Okay. Here, what do you have? How many moles? And we have the number of particles. So 3.15 times 10 to the power 23 molecules, okay, times what? 1 mole over the Avogadro number, which is 6.02 times 10 to the power 23 particles. So we can cancel molecules and molecules here, and you can find the answer by using the calculator. Okay. Here, how many formula units? And we have the moles. Same procedure, same steps. So 4.50 mole times what? Times 6.02 times 10 to the power 23 over 1 mole. You can cancel the mole to get what? To get the answer here. Okay. Here, how many moles? But we have here what? We have the grams. So how to convert from gram to mole? From a gram to mole? From mass to mole, or from a gram to mole? 191 gram times what? 1 mole over the grams here. What's the gram here? 63.546 gram. You can cancel the grams to get the answer, but you can use, you can use the calculator to find the answer. Here we have particles or atoms, and we need to find what? The mass in grams. So first we have to convert from particles to moles, then from moles to mass. Okay. So the first step is 9.60 times 10 to the power 24 atoms. Okay. Multiply by what? By 1 mole over the 6.02 times 10 to the power 23 atoms. So we cancel the atoms. We get the answer here. This answer is in what? In mole. The unit is in mole. So as you see, because we have mass, we have mole, we have particles. So first, to convert from particles to mass, we have to pass through what? Through the mole. So first, from particles to mole, this is the first step. Then this answer should multiply by what? by this answer is in mole. Okay, so where's the molar mass? Molar mass, this is the molar mass. So times 4 over 1 mole. So we can cancel mole and mole to get the answer. So 2 steps. First convert from particle to mole, then from mole to mass. Okay. Here, what is the central unit conversion between mass and particles? Mass and particles, we have to pass it through what? Through the moles. Because we have to convert from mass to mole, then from mole to particles. So the central atom, sorry, the central unit of conversion is what is the mole. Okay. Which of the following statements is correct about related the mass and mole? Okay, mass and mole. A mole always contains the same number of particles. Yeah, a mole of any substance contains the same number, which is 6.02 times 10 to the power 23 particles, which is an Avogadro number. Okay, which is the Avogadro number. So this is correct. Mole of different substances have different masses. Yeah, because that depends on the particle itself. Okay, so yeah, we know that we have, for example, let's say we have 6.02 times 10 to the power 23 particles of carbon. Okay, this number of particles has a mass different. You know, is different, not the same. If when you talk about, for example, aluminum or chlorine or any substance. Okay, so this is correct. Converting from mass to mole, we use fixed ratio of for all elements. No, because we have mass. Okay, so you have to use what? The molar mass, and the molar mass is not the same for the all elements. For all elements, so this is not correct because here we have mass. Okay, so to convert from mass to mole, okay, we multiply by what? By 1 mole over the number of grams or the molar mass. Okay, so the molar mass depends on the substance, so it's not a fixed ratio. Okay, so this is not correct. So the answer is what? Is 1 and 2. Okay. Okay. So here, what's the mass of this? So we need to find what? To convert from mole to mass. So to convert from mole to mass, 3.75 times 10 to the power 2 mole multiplied by what? By 6 point, this is the given, which is the molar mass, 63.55 grams over 1 mole. So then you can get the answer. Okay, I choose here. Here, what's the mass of this? Okay, same. 4.50 times 10 to the power 2 times, this is mole, okay, times, this is the molar mass, so 58.933 grams over 1 mole. We can cancel mole and mole to get the answer. Okay, here. A vessel contains this number of what? Of particles. They want me to find what? The mass. Okay. So we have particles, we need to find the mass. So we have to go from particles to mole, then from mole to mass. So we have 2 steps. The first step to convert from particles to mole. So 5.117 times 10 to the power 24 atoms. Okay. Times what? Times the 1 mole, okay, over the Avogadro number, 6.02 times 10 to the power 23. Okay, particles or atoms. Okay, so we can cancel the atom and atom to get the value of what? Of moles. Then this mole should be converted into what? Into mass. Okay, so this mole multiplied by what? By molar mass, which is this. Okay, because they said the nitrogen atom, by the way, not nitrogen molecule, because nitrogen molecules N2, not N. So here we have here 1 mole, and here we have 14, which is in grams. Okay, then you can find the molar mass. Okay, this one. What's the molar mass of what's the molar mass for nitrogen element? Okay, this is a very simple question. Where's the molar mass? Molar mass is the number here below. Okay, not the upper one, the lower one. So where's nitrogen? This is nitrogen. What's the molar mass? Molar mass of this. Okay, N or N2? No, N, because they said nitrogen element, so only N. So this is the number. We choose the number. Okay. Here, what's the molar mass of this compound? How to get the molar mass of this? Just look here. This is the molar mass of carbon, sorry. This is the molar mass of hydrogen. And this is the molar mass of what? Of oxygen. So how many C do we have? We have T, 2, sorry. So for carbon, we have 2 times what? What's the molar mass? 12.011 plus hydrogen. Hydrogen, we have here 5 hydrogen and 1 hydrogen. 5 hydrogen and 1 hydrogen. So we have 6 hydrogen times 100 plus oxygen. What do you have here? 1 times oxygen, which is 16. Okay, equals the answer. Then we choose. Okay, so we have 24, 30, 46. So it's about 46. Yeah, that's the correct answer. Now, what's the mass of this mole? Okay, of this. So the same procedure, we have mole and we convert to mass. So 3.25 mole times the molar mass, which is 98.08 mole over grams over what? Over 1 mole. So we cancel mole and moles, then we can use it to use the calculator to find the answer. Okay. Next question. What is the correct conversion factor to find the number of molecules? To find the number of molecules from the number of moles. Okay. So we have mole. Sorry. Yeah, we have the moles because we have to find the number of molecules. Okay. From what? From the number of moles. So we have to convert from mole to molecules. Okay. So how to convert from mole to molecules? Multiply by by 6.02 times 10 to power 23 over 1 mole. So this is the correct answer. Okay. 2. So this is the unknown. And this is the given. Okay. Mole. So we convert from mole to molecules. So to convert from mole to molecules, multiply by the Avogadro number over 1 mole. Okay. Here, how many molecules? We have the grams. Okay. So they ask me to find the molecules. Molecules means we need to find the number of particles. Okay. So first you have to convert from mass to mole, then from mole to particles. So 60 grams times this is the molar mass, right? So times 1 mole over this value, which is 180 grams. So cancel gram. Can get, by the way, 0.3 mole. Then use it. Okay, 0.3 or sorry, 0.33. Okay, so 0.33 mole. Okay, multiplied by what? By the Avogadro number, which is 6.02 times 10 to power 23 over 1 mole. You can cancel the mole to get the answer, and this is the answer, by the way. Okay, so the same procedure. Here, which of the following ratios conversion is incorrect, coefficient is incorrect? Calculations for the molecules of K, C2H3O2. Okay, so look, how many Ks do we have here? We have only one here. Carbon, we have 2. Hydrogen, we have 3. Oxygen, we have 2. Strike, look at the subscript here. So 1 molecule over 1, sorry, 1 mole of K. Yeah, 1 mole of K over 1 mole. Yeah, that's correct. 2 mole C, yeah, we 2 mole C. Okay, 1 mole, yeah, 1 mole. Because, we use here in the denominator, we use 1 mole. Okay, so 3 mole H, yeah, 3 mole H over 1 mole, 1 mole. 1 mole O, no, not 1 mole O, 2 moles of O. So this is the incorrect. Here, how many moles are in 22 grams of this? So we have the grams, we need to convert it to moles. So 22 grams times what? 1 mole over this value, which is 44. Then you can find it using the periodic table. The calculator. Okay, to convert from mass to mole. Here, how many carbon molecules are in grams? Also, we have to convert from gram to mole, then from mole to particles. So 307.6 grams multiplied by 1 mole over the molar mass, which is 153.8 grams. Okay, cancel the grams. You can get the number of moles. Then this mole, okay, should be multiplied by what? By 6.02 times 10 to the power 23 over 1 mole. You can cancel the mole with mole. Okay, you can get the answer here. Okay. So this is the question here. What's the number of moles of iron ions present in this? Okay. So they want what? The number of moles of iron. So look how to find it here. Look, they said what is the number of moles, and here we have mole. So look, mole to mole. But what's the difference here? What's the difference here? Here, this is 3.75 moles of what? Of the compound. 3.75 times, sorry, 3.75 moles of what? Of the compound. Okay, but here we need to find the number of moles of what? Of iron, which is just a component or one, only one element, okay, in the compound. Okay, so here we have the mole of the compounds, okay, and we need to find the moles of what? Of the iron. Where's the iron? Iron is Fe. So how to find it quickly? Just multiply by the subscript of Fe, because they are asking me to find the number of moles of iron. Okay, so we have subscript here too, so just multiply by 2. Okay, so to get the answer here, same was number of here sulfate ion. Okay, sulfate is what? Is SO4. How many SO4 do we have? We have 3. So multiply by this. Okay, to get the answer here. Sample has a mass. How many moles? Also convert from mole to mass. Sorry, from mass to mole. So 1156 grams times 1 mole over the molar mass of this. Do we have the molar mass? No, we have to prepare it. How? We have CaSO4. So how many Ca do we have? We have 1 times what's the molar mass? Molar mass is 40 plus S. How many S do we have here? We have 1. So 1 times 32 plus O. How many O's do we have here? We have 4. So 4 times 16. 40, 72, 72. Here we have 64. So here we have 72. Let's count it. 72 plus 64. Okay. So 136. Okay. So here we use the molar mass here. Okay, 136 grams. So we can cancel the grams to find what? To find the number of moles. Okay. Here they give us the grams and want me to find the number of moles. So 884 grams times what? How many moles? So we have to multiply by what? This is similar, by the way, similar to this. Okay, just here we have 1156 grams. Here we have 884 grams. So use the same procedure in the previous question. Okay, here we have what's the mass, and we have the moles. Okay, so we have to convert from mole to mass. How to convert from mole to mass? 3.25 mole multiplied by molar mass, which is here 98.08 gram over 1 mole. You can use the calculator to find it. Okay, here, what's the molar mass of the compound? How to find it? Look, Al, this is Al, S, this is S, O, this is O. So how many Al do we have? We have 2. So 2 times this number. This is for Al. Plus, what about S? How many S do we have? We have 3. Okay, because we have a bracket. So we said we needed Al2SO4 by 3. So S is multiplied by 3 and O is multiplied by 3. So 3 times the value of S plus O. How many O's do we have here? We have 12. So because we have 4 times 3. So 12 times the value of O. Then use the calculator to find the answer. Okay. Which of the following statements are correct? To do the molar mass of and the mole. Okay. The molar mass of an element numerically equal to its atomic mass. Yeah. Molar mass numerically, okay, in terms of number, not unit, is equal to what? To atomic mass. This is, by the way, this is mentioned in the book, okay, in your book as definitions, okay. So they are equal, yeah. Subscript of the chemical formula. Subscript. Where's the subscript? Subscript here. This is the subscript. 2, 4, 3. This is the subscript. But the number in front of the compound is called what? It's called coefficient. Okay, subscript of the chemical formula indicates how many moles of each element are present in 1 mole. Okay, so they said here the subscript, okay, indicates how many moles of each element are present in 1 mole. Yeah, this is correct because look, where here? Not this question. Yeah, here. Here, how many moles here? We have 2 moles of Fe, okay, in 1 mole of the compound. 2 moles of Fe in 1 mole of the compound. But if we have 3.75 mole, we have to multiply by what? By the number of moles here. Okay, so the subscript here represents the indicates the how many moles. The molar mass of a compound is calculated. The molar mass of the compound is calculated from the molar mass of elements in the compound. Yeah, that's correct. So let's stop here. Okay. السلام عليكم ورحمة الله.